Hi guys, I'm back. Just like with pyramids and cylinders, I thought cylinders were much easier because their bases were always circles. The same is going to be true, in my opinion, of cones and pyramids. For pyramids, you could have any polygon for the base, whether it be a square, a hexagon, an octagon, whatever the case may be. But a cone is always going to have a base that is circular. Okay. And it'll still have a vertex where it meets right here at a point at the top. So in a right cone, which is the type that we are going to go ahead and look at, the altitude, also known as the height, is going to be the perpendicular segment that goes from the vertex to the center of the base, or the center of the circle. So again, we're going to represent that with um, this capital H. So that blue line is going to be the height. But just like with the pyramids, in addition to the height, again, capital H, we're also going to go ahead and have a slant. Okay, and again, still same thing, lowercase cursive l. So we have our height, and we have our slant height. And our slant height is just going to be represented using the distance from the vertex to any point that is on the edge of that circle, which is going to be our base. So this pink line, okay, is going to go ahead and be our slant height. So again, we have our height with capital H, and we have our slant height. Okay. Now, the lateral area of a cone is also going to come from the pyramid, just like the cylinder came from our prism. So keep in mind the lateral area of a pyramid is 1/2 the perimeter times the slant height. Now, the only thing that is different is that when we're working with circles, okay, we have a different name for perimeter. So in a circle, if you guys remember, this would actually be called our circumference. So our circumference is 2 pi r, which again is on your formula sheet. Everything else still stays the same. It's still 1/2 and it's still a slant height. But the cool thing happens here where this 2 and that 2 reduce down to 1. So actually the lateral area of a cone, and I apologize, there's a typo on your note sheets here, should just be pi r l, where r stands for your radius and l stands for your slant height. And then same thing down here. So we have our cone. Again, I apologize for that. So we're going to take our lateral area and add on a single base. Well, in a cone, our base is always going to be a circle, and the area of a circle is always going to be pi r squared. So, moral of the story here is once you know a radius and a slant height, you can very easily find your lateral area and your surface area of your cone. All right, let's go ahead and flip really quickly to the back page here. I'm going to do one of these with you guys, and then I'm just going to give you a few hints and tips on 5 and 6, and then I'm going to let you guys try those with your groups. So I'm noticing an issue right away. Remember I told you that you really only need to know 2 things. You need to know your radius, which I think we'll be okay with in problem number 4, but you also need to make sure you know that slant height. We're not using a capital H, we're using that lowercase cursive l. So as I said, I think we'll be okay with the radius because if the whole diameter is 8, my radius will be half of that. But the hiccup that I'm having is I really do need to know that yellow line there, that's slant height. So off to the side, I'm going to do a little bit of work here. Remember, we know 2 sides. We want to know the third. He's old. He's awesome. He's Pythagoras. So leg squared plus the leg squared is going to be equal to the hypotenuse squared. I have 16 plus 56.25 equals L squared. I add those together. I get 72.25 equals L squared. I take the square roots, and it's not as horrible as I thought it was going to be. We do get a nice decimal of 8.5. Now I'm ready to actually go ahead and do some of my work here. So my lateral area is going to be pi r l. So my r is, whoops, sorry about that. My r is 4. All right, let me grab my eraser. Here we go. And my slant height is the 8.5. And so I end up with a lateral area of 34 pi centimeters squared. Remember on your quizzes and your tests, I'm going to ask you guys to give exact answers. So we're going to leave this in terms of pies and radicals and all those fun things. Now, find my surface area. Okay, I'm almost done here. I'm going to take that lateral area and add on just one base. And again, my base this time happens to be a circle, so it's the pi r squared. So in this case, I'm going to add on a pi 4 squared, or I'm going to add on a 16 pi. Because 34 pi and 16 pi are like terms, I can actually add those together, and I get 50 pi centimeters squared. Okay. All right, I'm going to ask you guys to do the last two problems with your group. Now, these composite figures, like problem number 5, can get tricky. I know the directions say to find the surface area, but really truly think about what you want. Do you want to add on the bases or not? Because anytime that you say surface area or look on the formula sheet for surface area, that's including your bases. When I look at problem number 5, I'm thinking to myself, okay, for this cone, I want to round the outside here, that lateral area. I can't touch that blue base. So I don't want to actually add that into the problem. So I'm going to do my lateral area for the cone. Sorry, jumped down there. Same thing with my cylinder. I'm going to go ahead and do my lateral area there. And I can't touch this blue top, but I can touch that green bottom. So I am going to go ahead and add on just one base when I'm done. And then last but not least here, you're going to try to find how much filter paper we need for our funnels. So again, think to yourself, what do I really want here? Do I want my lateral area or my surface area? All right, why don't you guys go ahead and pause me here. We will compare answers in just a little bit, but please go ahead and work with your group for the next few minutes on these bottom two problems. All right, I'm back. Hopefully you guys have had enough time to work. Went through and noticed, first of all, that my radius down here was 3, so it must be true at the top. One of my Pythagorean triples is the 3, 4, 5 triangle, so I knew my slant height was going to be 5. I went ahead and just calculated them separately, so I did the lateral area around the outside of the cone, and I got 15 pi. I did the lateral area of my cylinder and got 48. And again, the only base that I can touch is this bottom green base here at 9 pi. When I added those all up, because they are like terms, I got 72 pi units squared. Okay, again, make sure you don't add in too many bases. All right, last but not least, we're doing our chemistry lab and we're using a filter inside my cone here. And the first thing I noticed is I didn't have my slant height, so I can go ahead and do my Pythagorean theorem. I had something around this in my calculator. I went ahead and in the end actually ended up rounding up to the nearest millimeter just to make sure that I had enough paper for my filler. All right, you guys did an awesome job today on your notes. Please do not forget tomorrow to make sure that you put your computers charged. We will be playing a game tomorrow during class to prepare for Monday's quiz. So you do have a quiz on Monday, and tomorrow you guys are going to be playing a game. Other than that, I hope you guys are all doing awesome. I will see you Monday morning.